There is a different way of presenting the linear model for a one-way ANOVA. The results are the same as the previous one, but there is a slight difference that could be useful in more complex models. So, remember what we did in the previous case is to assign a reference group, which was A, and then that the beta 0 was the value of the mean of A, and then beta 1 was the increase from A to B, and beta 2 was the increase from A to C. Now we are going to use a different tactic. Beta 0 will be the mean total. And the mean total, it's in this case 18.33. So instead of creating two dummy variables, we now have to create three dummy variables. One called XA, another XB, another one XC. So we have the additional one is XA, in which we are going to have one for the group A, B equals 0 and C equals 0. So beta 1 will be the increase between beta 0, the total mean, and the mean of group A. So this increase from beta 0 to the mean of group A. So remember it was 20, so the increase will be 1.66. Beta 2 is the increase from the mean total to the mean of B2, so from 1833 to 25. So that would be 6.66. And beta 3 is the increase from beta 0 to the mean of group C, which is 10. So beta 3 is minus 8.33. And if you add all these betas, 1.66 plus 6.66 minus 8.33 should be 0. They should cancel. Okay, so let's do the same. Let's replace for group A. I'm going to change color to make it a bit somehow tidy. So let's do for group A, we replace XA is for group A is 1, and XB is 0, and XC is 0. So we are going to have 1, 0, and 0. For group B, XA is 0, XB is 1, and XC is 0. So we got 0, 1, and 0. This is for group B. And for group C, we've got XA is 0, XB is 0, XC is 1. So 0, 0, and 1. So if we do here in the three cases, it will be 18 plus 18.33 plus the rest of the equation. So in the case of A, it will be 1.66 times 1, and then the rest will cancel because you multiply by 0. In the case of group B, you are going to do 1.6.66, so that would be added to 18.33, but the other two, they cancel because they multiply by 0. And in group C, you're going to do 18.33 minus 8.33 because the other two cancel because they multiply by 0. So that's the way we've got the gamma for the three groups, and then the standard deviation, and then we've got a normal distribution for each of the three groups, as we mentioned in the previous case.